All right, so we're back to one of these prove or disprove type things where we need to learn the rule. What happens when you have the same coefficient but different items inside the square root? Can you add them, and what happens when you do add them? So let's try some examples. Again, let's take ones we know. So, I know square root of 4 and the square root of 25. So let's use B 4 and A as 25 and try this. So we know the left side should compute to, let's see, 5 square root of 4 plus 5 square root of 25 equals, this is 10 plus 25, which is 35. So 35 is what we're seeking with these numbers. So let's try it out. Is 10 times the square root of A times B 100, is that the same as 35? Well, square root of 100 is 10. Times 10 is 100. So we know that choice A does not work. What about choice B? 10 times the square root of 4 plus 25, is that the same as 35? Well, no, it's 10 root 29, and we know square root of 29 is not a perfect square, which means it can't give us an integer solution. So it's definitely not B. What about C? And what if we just, maybe we keep the coefficient, and then we just add the bases. Let's try that. C, 5 square root of 4 plus 25. Well, wait a second, we're in the same problem here with the square root of 29, so it cannot be that. D, 5, so this just looks like it's the same as that, right? So that should obviously be the same because, something is the same as itself. But just to make sure, 5 root 25, which is 10 plus 25, 35. So that definitely works. None of the above. Well, we know D works. And I think no matter what numbers I try, that should work because I'm saying something is equal to itself. So there's no way that that can't always be true. So in this case, when you don't have the same base, there's nothing you can really do to consolidate these. And students will try all sorts of things, like A and B and C. And when you don't have the same thing inside the square root, they are not like terms, so they cannot be combined.